Hi everybody, we're going to start with normal form and finding the normal form of a set of pitches, a pitch class set. So we'll start here with this set right here, this first measure. This is my original set. Okay, I've got a D, E flat, F sharp, A flat, B, C, or if I use the integer notation, 2, 3, 6, 8, 11, 0. That's the version that I was originally given, let's say. So what I want to do is I want to find the most compact form. In order to find normal form, I want to find the form that's the most compact, where the interval between the first and the last interval are the smallest. Okay? So we have our original set right here, which are these notes right here, and we're going to try to find the normal form. So what I've done here is I've taken this original set right here, and I've taken it through every possible rotation. So the first thing you probably want to do is just take all the pitches and put them in ascending order from 0 to 11. So put 0 on the bottom all the way up to 11, and they're in ascending order from smallest to largest. Okay, that's the first step. And then I'm going to just take each ordering that I can find. So then I'll put 2 on the bottom, and the 0 is going to move its position to the top. Then I put 3 on the bottom, the same order, but then 2 goes to the top. So each time I'm taking this first note and I'm moving it to the top. Okay? This is a longer pitch set, so there are a whole bunch of different permutations of the ordering. Okay, that's the first thing we want to do. Now, in order to find the normal form, we need to find the one that has the smallest interval from the first note to the last note. So you can either just look at the two notes and name the interval, like with traditional words, like you can call this a major seventh. So here, this one's a major seventh. The other thing you can do is you can subtract the top number from the bottom number. So 11 minus 0 is 11. So you can name intervals when we're talking about set theory. You can name intervals just by the number of half steps. So major seventh, or you can call it 11 half steps. Okay, this next one here, we have a minor seventh from the D to the C. So this one is already smaller, okay? If you wanted to do this mathematically, you could also subtract 0. You could take 0 minus 2, which would give you negative 2. We don't use negative numbers. We're using what they call, sometimes my theory teacher called it mod 12 arithmetic, which is all the numbers have to be between 0 and 11. So if you have something outside of that, like negative 2, then what you do is you add 12 to it to get it into that range. Basically, if you think about it, it's as if all of the integers, they're all equivalent, you know, like every 0 is C, and if you add 12 to that, you have 12. 12 is also a C. If you add 12 to that, that'd be 24. That's also a C. So as long as if you can add or subtract 12, and you still have an equivalent pitch class. So if you have a negative number, negative 2, add 12 to it, and you'll have 10. So this interval is a minor seventh. Anyway, the point is, it's a smaller interval than this one. So we're going to get rid of this, because we're looking for the smallest ones. We already know that this one's not. This is not the answer. This one here is a minor seventh. It's a candidate. Let's see what we have over here. We have an E flat going to a D, which is a major seventh. So that's bigger than our minor seventh. So that's out of the running. That's not going to be the normal form. Here we have a F sharp going to an E flat. So you can think of that enharmonically. If I thought of this E flat as a D sharp, then I would have a major sixth. That's our smallest interval so far. You can also think of it numerically. So take 3, subtract 6, you have negative 3. What happens if you add 12 to negative 3? You have 9, right? So that's your major sixth. So far this is the major sixth is our winner. So let me just subtract that one. We know that anything bigger than a major sixth is not going to be our normal form. Okay, what do we have here? A flat going to F sharp. That's an augmented sixth. That's too big. So that's because right now the smallest one so far is the major sixth. So it can't be that one. And let's see what this one is here. B to A flat. Well, let's say that it was a G sharp, same note, right? We don't care about enharmonics. That's a major sixth also. So these two are the same. They're both they both have the same outside interval. So we've got a tie right here. So then the next thing we do is we go to the next smallest interval. So we're going to compare this interval here from the F sharp to the D to this interval here, the B to the F sharp. So F sharp to the D, that's a minor sixth, or we could do it numerically. 2 minus 6 is negative 4. Add 12 to negative 4, and you have 8. It's a minor sixth. Versus 6, that's our top number here. 6 subtract 11. What do you get? Minus 5. And then I'm going to add 12 to negative 5, and I'd have 7. So we've got a perfect fifth, or 7 half steps, versus a minor sixth, which is 8 half steps. So this one here is our winner. So I'm going to get rid of this one here. So we found a winner. So we didn't find it with the outside interval. We had to go to the next largest interval in order to find the normal form. So here is our normal form. Normal form. Excellent. Very good. All right, let's now find the normal form of this next set that we're given. So the first thing we want to do is take all of these pitches and we're going to put them in ascending order, okay? So I'm going to start with the lowest one, which is an E flat, and I'm going to put it down here. The next one is the F. The next one up is the B flat, and the next the next one up is the A flat, and then we have a B flat. Okay, so here we are in normal form. Okay, and then I'm just going to add the numbers to that. Okay, so now that I have the original set, but I've put it in ascending order, I've found a little shortcut that I've been using that seems to work pretty well, because I want to take it through all of its rotations. So I'm just going to take this and I'm going to copy it a few times. Copy it. That should probably be enough. Okay, so that is going to make it very easy for me to figure out to just rewrite some of the rotations. So I'm going to take this one. I'm going to just take from the first note to here. You'll see what I mean. You'll see what I mean. Like that. And then I'm going to go from here to there. This one here. And then I'm going to go from the last note. This just makes it go a little faster for me. So then I'm going to go ahead and get rid of these measures here. So you see what I did? I just changed the order. I just rotated the order. So I started with the second one, then I started with the third one, and then the fourth one. Now I'm going to change the octave placement just because it's a little easier for me to visualize if I go like this. So these two notes can be an octave higher. It doesn't change the integer. It just changes where they are on the staff. And I don't know, maybe it's just me, but it makes it a little easier for me to visualize what's going on here. So I've got these 4 notes and all 4 possible orderings. Okay. Now what I'm trying to do is I'm trying to find the normal form. So I'm just going to compare the outside intervals. Okay. So this one here is a perfect fifth. Perfect fifth. Or I could say 10 minus 3, which is 7 half steps. Same thing. Perfect fifth, 7 half steps. Whichever you want is fine with me. Okay. This one here is minor seventh. Minor seventh, that's bigger than a perfect fifth. If you like numbers, you can go 3 minus 5, which gets you 3 minus 5 gets you negative 2. Then I'm going to add 12 to that. So negative 2 plus 12 is going to equal 10 minor seventh. This one is not going to be our normal form. It's too big. So I'm just going to delete it. Okay. Here, I've got A flat going to F. That is a major sixth. Too big. That's not it. This one here, I've got a minor seventh. What's bigger than a perfect fifth? So that's not it. So we didn't have any ties. So here we are. This is our normal form right off the bat. That was easy. That was an easy one. I love the easy ones. Okay, you're probably starting to get the hang of this now, but let's do a few more just to be sure. So we're going to find the normal form of this pitch class set here at letter C. So I'm going to do the same thing I did before. First of all, I'm going to it already actually is in ascending order, so I don't have to do anything. You see it goes 0, 4, 5, 8, 9. It's already in ascending order, so that helps a lot. So this is just my little shortcut here. I just copy, I guess I really only need to copy one of them. I don't really want this lyric here. Let's get rid of the lyric. Okay, so what I'm going to do is I just want to find all of the possible orderings. So, oops. This one, I already have the one that's the original one, starting with the first note. I'm going to just copy right there. So I just highlight everything. I'll give myself a measure so I know where I started. I just highlight starting from this note, and I go all the way to the first note on the next measure. Okay, and then I'm going to start with the F, and I'll go all the way to the E. Copy that, and I'll put that over here in this measure. Then I'm going to start with the A flat. I'll go all the way to the F, and I'll copy that over here into this measure. And then finally I need to start with the A, and go all the way to the A flat. Okay. Alright, so now I can get rid of these two. Let's see, remove select range. Okay, and then, like I said before, I like to just have them, I like to place the octave, redo the octave placement so that I can see them all as like ascending pitches, like that. You don't have to do that, but it makes it easier for me. Then I can sort of confirm. You know, we're comparing the intervals. I like to be able to check the interval. I just look at the interval, and since I've taken a lot of music theory, I can say, oh, this one here is a major sixth. And then if I want to just double check, I can also do it the numerical way. So I can subtract 9 minus 0, which is 9. So half steps, major sixth. So far, this is our winner, major sixth. Let's see what this one is. We've got an E going up to a C. Well, that's a minor sixth. Numerically, 0 minus 4, negative 4, add 12, 8 half steps. Okay, so minor sixth is our winner. So I'm going to get rid of this first one now. I'm trying to see if I can find an ordering that makes it smaller than a minor sixth. This is a major seventh. That's too big. This is a major sixth. Okay, and then the last option here is this ordering here, where we're going from the A up to the A flat, or you could call it G sharp. I see that as a major seventh. You could also do the numeric way, 8 minus 9, negative 1. And then we're going to add 12 to that. It's going to give us 11. So that's definitely no bigger than this one over here, which is a minor sixth. So I think we've got our normal form here. Oops. Which is this one. Let me go ahead and get rid of this measure here. We've got our normal form right here. Go normal form. All right, let's take a look at number D now. And as you can see, first thing we need to do is we don't have it in ascending order. We don't have it going from the smallest to the highest integer. So that's the first thing I want to do. So I'm just going to do that manually over here. Okay, there we go. So I've got them in ascending order. It's not necessarily in normal form yet. We don't know. So I'm just taking all of the possible ways to order that pitch class set. Let's go ahead and get rid of all that. Okay, and lastly, as always, I like to change the octave so it actually looks like they're all going up. It's easier to calculate the intervals for me. If you do it numerically, it doesn't matter, but if you want to visually see it, that's how I like to do it. Okay, so let's start finding the normal form. So right here we've got C sharp going up to A flat, or you could if you think of it as D flat going up to A flat, same thing, and you have a perfect fifth. So right now it's a perfect fifth is our lowest one. Let's see what this one is. This is a perfect fifth, augmented fifth, or a minor sixth. That one's bigger, so this one's out. F sharp going all the way up to F, that's a major seventh, so that one's out. It's bigger than a perfect fifth. And then finally, we've got A flat to F sharp, which is an augmented sixth. That's big. Okay, so we had an easy one, no ties. So here we go. We've got our normal form right here. I'm just going to write normal form. And finally, the last one for us to look at is letter E. 1, 2, 3, 4, 5 pitches. When I do this in MuseScore, I change the time signature to have the same number of quarter notes as the number of pitches in my pitch class set. Call that the cardinality. So this pitch class set has a cardinality of 5. So I put the time signature in there just so that they all fit on one measure. Okay, so yeah, you can start by putting them in ascending order. That's probably a good thing to do. Okay. Now here's my little shortcut. So I just come over here somewhere, anywhere, and I just copy it a couple of times. I think I only need to copy it twice, actually. Okay, so now I'm just going to take all of the rotations of this set where I've got them here in ascending order, and I'm just going to take all of the different orderings. This one we already have, so now I need one that starts on E flat. I'm going to go all the way to the D flat. I'm going to copy those pitches and put them right there. Then I'm going to start here on the A flat. Okay, so, and finally, I'm going to, not finally, but the next thing I'm going to do is change the octaves so that they all look like nicely ascending lines. There we go. Okay, here we go. Now I've got the different orderings, the 5 different orderings of this pitch class set. Cardinality 5, you're going to have 5 different orderings because you have 5 different starting notes. Okay, so we're trying to find the normal form, so the most compact. Major 6, that's what we have so far. Let's see what this one is. It's a minor 7th. Okay, that's out. That's bigger than a major 6th. Let's get rid of that one. This next one here, from the A flat to the E flat, oh, that's a perfect 5th. That beats a major 6th. So we can get rid of this one. So far our smallest interval is the perfect 5th. Okay, let's see what we have over here. A to A flat. Ooh, gotta get some juice here. Juice. This one here goes from A to A flat, which is a major 7th, and harmonically speaking. All of these you can do numerically as well, so you could take 8 minus 9, which is going to equal -1, and we need it to be somewhere between 0 and 11, so if we just add 12 to -1, then we're going to have 11, so 11 half steps, major 7th. In any case, it's bigger than this perfect 5th over here, so this is not the winner. And finally, B flat to A, that's another major 7th. Too big, that's not the winner. So it looks like we have no ties. It's nice when we have no ties, it's just one less step for us to have to do. So it looks like we've got our normal form here. This is the most compact way of ordering these pitches here. So this is our normal form. Normal form.